All right, so today's question, does an allyl cation only have three carbons or can it have more? The short answer to this is that yes, it can only have three carbons. And that's because people who've come before me have defined that the allylic intermediate that this question is referring to is derived by detachment of one hydron, which is H plus, which notice it has no electrons on it. I'm not putting any dots here or saying it's literally just a proton would be, I think, another definition that should be fair. There is also the removal of one hydrogen or a hydride, which, if it's not H plus, it could be H minus, which includes both of the electrons. So the first electron is kind of taking the cation and saying, well, you're not a cation anymore, proton. You have one electron. We have neutral. Or if I take two electrons, then it would be now minus. And so this can be thought of as a bonded hydrogen that's removed. And so if I'm mechanistically taking those electrons in that line with me, then I would be detaching a hydride. Let's just go back for a second and say, what about when I remove a proton? What does that look mechanistically? Well, that would be me coming in and taking the hydrogen, and the electrons go on to the atom that the H is connected to. So I'm taking just the H, and the two electrons are going onto the atom. Mechanistically, this would be how we see it. Or one that I don't want to cover too much in this video is hydrogen itself, which is really just H and its single electron. And so this is going to be more of a possibly a radical chemistry. So I don't want to focus on that in this video today, but instead I want to just say that yes, indeed, if this is our definition, it ends by saying from the CH3 group of propene, which is defined as this three-carbon system. Oops. Which is defined as the three-carbon system that this student is asking about. And so we'll kind of highlight that this is the CH3 group we're talking about here. And so, as defined, there is indeed one carbon, two carbon, and three carbons. However, I do want to note that this student might be asking, can we have, let's say, a system where we're no longer talking about propene, but effectively we have a diene with a CH3 on it. It's substituted with this CH3 group. We would still probably, I think, accurately define that the, let's say, cation, so let's remove the hydrogen and its electrons, and resulting in now this being a C+, having this p orbital there. And I'll try and shorthand this just a little bit. Well, an attempt was made, but not successfully. And so we have here, right, this, let me circle this. I'd still define this as somewhat accurately described as an allylic cation, but some people might disagree with me. And so where am I getting this answer from? Well, there's a really important resource that's called the IUPAC Gold Book. So when I Google the IU Gold Book, I can kind of get to this webpage where I can start to search what have people before me defined these terms that I want to explain to students accurately. And so, for example, I can look up what is a cation, make sure I'm answering that correctly for this student. And so this does have a carbon that has an elementary charge of the proton, the +1 in this case to some degree. And then this is where I'm talking about an allylic group. It's interesting because it says, and derivatives formed by substitution, such as OH attached to an allylic site, is sometimes described as allylic. And so I'm starting to wonder to myself, I guess if your substitution of your allylic group is a long chain of alkenes, you can still say this part of it would be allylic. And so what the student is asking about is an allylic intermediate. And this is where I kind of got my definition of all these things to provide this with. And of course, making sure I know what all these terms mean, because I can click one of these and go to a new page. So again, if you have your own questions and want to start looking up terminology, you can start kind of searching different things that you want to give the correct answer to, and then maybe explain a little bit more clearly some of these terminologies for students. But great resource for you to use, and I hope that helps with the question. So comment below if you have more questions or if there's a mistake in this video.